Welcome everyone. Today, let us step into an alternate version of history and ask a simple but powerful question. What if electricity had been discovered 1,000 years earlier than it actually was? This single shift in timing could have quietly reshaped everything we think we know about the Middle Ages and the path of human progress. If electricity had emerged around the year 1000, the medieval world would no longer resemble the slow, dimly lit era we imagine today. At that time, daily life depended almost entirely on fire, animal labor, wind, and water. Once the sun set, productivity largely stopped. Knowledge spread slowly, limited by distance, darkness, and manual effort. Electricity, even in its most basic form, would have broken those limits. Early electric light alone would have changed the rhythm of life. Workshops, monasteries, and learning centers could function long after nightfall. Reading, writing, and teaching would no longer be constrained by candles and oil lamps. Cities would feel safer, more active, and more connected, encouraging population growth and cultural exchange. The labeled Dark Ages might never have existed at all. Beyond daily convenience, the presence of electricity would have altered how people understood the natural world. Medieval thinkers, instead of relying primarily on tradition and authority, would have been pushed toward observation and experimentation much earlier. Curiosity about invisible forces, currents, and energy would encourage systematic study, laying foundations for science centuries ahead of schedule. As a result, the Middle Ages would not be a long pause between ancient and modern times, but a launchpad for rapid advancement. Rather than waiting hundreds of years for technological momentum, humanity might have entered an age of innovation far sooner. And from that single early discovery, the entire timeline of civilization would quietly shift, leading us toward a very different world than the one we know today. The introduction of electric lighting in the medieval era would have fundamentally altered how people lived, worked, and learned. For centuries, human activity was closely tied to daylight. Once night fell, productivity dropped sharply, limited by weak candlelight and costly oil lamps. Early electric light, even if dim and inefficient by modern standards, would have broken that natural boundary and extended usable time every single day. Workshops and craft centers could operate longer hours, allowing artisans to produce more goods and refine their skills. This increase in output would gradually strengthen local economies and trade networks. Markets could remain active after sunset, turning cities into lively centers rather than places that shut down with the fading light. Urban life would become denser and more organized as people adapted to longer, brighter days. Education would benefit just as dramatically. Monasteries and early schools, which served as the main centers of learning, would gain the ability to study and copy texts at night without straining eyes or risking fires. More books could be produced, knowledge preserved more accurately, and literacy expanded beyond a small elite. Over time, this would nurture a culture that values learning, discussion, and shared ideas. Public safety would also improve. Well-lit streets reduce accidents and discourage crime, making cities more attractive places to live. This sense of security would encourage migration from rural areas, accelerating urban growth much earlier than in real history. Perhaps most importantly, electric light would subtly change how people perceived time itself. Night would no longer represent a hard stop, but simply another phase of the day. This psychological shift would push societies toward efficiency, planning, and innovation. Long before modern industry, the simple ability to control light would quietly reshape daily routines and set humanity on a faster path toward progress. The discovery of electricity in the medieval era would have reshaped how people approached knowledge and understanding. Instead of viewing the natural world as something governed only by tradition or authority, scholars would be confronted with a mysterious force that demanded explanation. Electricity cannot be easily seen, yet its effects are undeniable. This alone would push thinkers toward observation, testing, and evidence-based reasoning far earlier in history. Medieval scholars were already curious, but their tools and frameworks were limited. With electricity, experimentation would become unavoidable. Simple questions: why sparks appear, why certain materials attract each other, or how energy travels would encourage systematic investigation. This shift would slowly weaken purely philosophical explanations and strengthen experimental methods, laying the groundwork for modern science centuries ahead of time. As understanding deepened, related fields would begin to emerge naturally. Studies of magnetism, energy transfer, and basic electrical principles would blend with early chemistry and physics. Instead of isolated discoveries spread across hundreds of years, knowledge would build more continuously. One insight would lead to another, creating momentum that medieval society never experienced in reality. Institutions of learning would evolve as well. Universities and monasteries would move beyond preserving old texts and become centers of experimentation and discovery. Scholars would share results, debate findings, and refine ideas, forming early scientific communities. Knowledge would no longer be static. It would be something actively expanded. This change in mindset might be the most powerful consequence of all. Once societies learn that nature can be understood, measured, and harnessed, progress accelerates rapidly. The scientific revolution, rather than appearing suddenly in the early modern period, would unfold gradually during the Middle Ages. From that point forward, humanity's relationship with knowledge would be permanently transformed, pushing civilization onto a much faster and more curious path of development. Once electricity became part of medieval understanding, entirely new fields of study would begin to take shape much earlier than in real history. Electricity naturally leads to questions about forces, matter, and interaction. As scholars explored these ideas, early versions of physics and chemistry would start forming long before the modern era. The study of magnetism would likely appear first. Observations of attraction and repulsion, combined with electrical effects, would push thinkers to search for underlying rules. This would encourage measurement, classification, and repeatable experiments. Instead of relying on symbolic explanations, scholars would focus on cause and effect. Over time, this mindset would redefine how natural phenomena were explained. Chemistry would also advance faster. Experiments involving metals, conductors, and reactive materials would reveal that substances behave differently under electrical influence. Alchemy, which already existed in the medieval world, could gradually evolve into a more structured and practical science. The focus would shift from mystical transformation toward understanding materials, reactions, and energy exchange. These emerging sciences would not develop in isolation. Progress in one area would support advances in another. Improved understanding of materials would enhance electrical tools, while better tools would enable more precise experiments. This feedback loop would accelerate discovery in a way medieval society never experienced historically. As these disciplines matured, they would influence education and industry alike. Students would be trained not only to memorize classical texts but to test ideas themselves. Skilled craftsmen and scholars would collaborate, blurring the line between theory and practice. Over time, knowledge would become something dynamic and expandable rather than fixed. By the time later generations arrived, they would inherit a world where scientific thinking was already deeply rooted. Physics and chemistry would no longer be future revolutions waiting to happen, but established paths of inquiry guiding human progress centuries ahead of schedule. With electricity already understood at a basic level, the conditions needed for a scientific revolution would appear far earlier than they did in real history. Instead of waiting until the 16th and 17th centuries, a gradual but powerful shift toward systematic science could begin during the Middle Ages. At this stage, scholars would no longer rely mainly on ancient authorities to explain the world. Observation and testing would become essential tools for discovering truth. When electrical experiments produced repeatable results, it would become clear that nature follows consistent rules. This realization alone would challenge long-standing intellectual traditions and encourage independent thinking. As experimental methods spread, knowledge would advance more quickly. Ideas would be tested, corrected, and improved rather than accepted without question. Written records of experiments would circulate among scholars, allowing discoveries to build upon one another. Over time, this shared approach would form the foundations of a scientific community. Technology would benefit directly from this change. Practical inventions would no longer be rare accidents but the result of deliberate investigation. Tools, machines, and early devices would be refined through testing rather than guesswork. This would create a steady flow of improvements across agriculture, construction, and craftsmanship. The impact on society would be profound. A culture that values evidence and reason tends to innovate faster and adapt more easily. New generations would be taught not only what is known, but how knowledge is created. This mindset would slowly spread beyond universities into everyday life. By the time later historical figures would have appeared, the intellectual groundwork for modern science would already be in place. The scientific revolution would not be a sudden break from the past, but a long process that began quietly in medieval times and reshaped civilization far earlier than expected. The ability to transmit signals using electricity would dramatically change how medieval societies functioned. Even simple electrical communication, similar in concept to early telegraph systems, would reduce the limits imposed by distance. Messages that once took days or weeks to deliver could travel far more quickly, altering the pace of decision-making across entire regions. Governments would feel this impact first. Rulers could coordinate policies, military movements, and resource management with far greater efficiency. Local officials would no longer operate in isolation, and authority could be enforced more consistently across large territories. This improved coordination would strengthen centralized power and allow states to function with a level of organization previously impossible. Trade and commerce would also benefit. Merchants could share information about prices, shortages, and demand in near real time. Markets would become more responsive and interconnected, encouraging economic growth. Long-distance trade routes would be managed more carefully, reducing uncertainty and risk. Social life would shift as well. Faster communication would change how communities relate to one another. News, warnings, and announcements could spread quickly, creating a shared awareness across regions. This would slowly form a sense of collective identity beyond local villages and towns. However, this transformation would come with consequences. Control over communication systems would become a source of power. Those who managed the networks could influence information flow, shaping public understanding and political outcomes. Access to communication might be limited at first, increasing inequality between regions and social groups. Despite these challenges, early electrical communication would mark a turning point. By shrinking the world long before modern technology, it would push societies toward greater complexity, coordination, and interdependence, setting the stage for a much more connected civilization centuries ahead of schedule. As electrical communication became more reliable, political structures would begin to change in fundamental ways. In the medieval world, power was often decentralized because rulers struggled to control distant regions. Slow communication meant delayed responses, local autonomy, and frequent disorder. Electricity would remove many of these limitations. With faster information flow, central authorities could respond quickly to events across their territories. Laws, orders, and updates could be transmitted efficiently, reducing the independence of local leaders. This would encourage the growth of stronger governments capable of maintaining consistent policies over wide areas. Smaller feudal systems might gradually give way to larger, more unified states. Administration would become more effective. Tax collection, census records, and resource distribution could be managed with greater accuracy. Governments would gain clearer insight into their populations and economies, allowing better planning and long-term strategy. This level of organization would be unprecedented for the medieval era. Military coordination would also improve. Troops could be mobilized and directed with better timing, reducing confusion and delay. Defensive responses to threats would be faster, making large states more stable and harder to disrupt. Over time, This stability would encourage population growth and economic expansion. However, increased state power would not be purely positive. Stronger control could limit personal freedom and reduce local decision-making. Those in authority might use communication networks to monitor behavior or suppress dissent. The balance between order and autonomy would become a central challenge. Overall, electricity-driven communication would push societies toward scale and structure. Political systems would grow more complex, borders more stable, and authority more centralized. The medieval political landscape would evolve rapidly, creating early versions of modern states centuries before they historically appeared. Once electricity began powering basic machines, the medieval economy would enter a phase of transformation far earlier than expected. Combined with existing mechanical knowledge, electric power would dramatically increase efficiency and production. Tasks that once depended on human or animal labor could be partially automated, changing how goods were made and distributed. Workshops would gradually evolve into early factories. Instead of small-scale manual production, centralized spaces could use electrically assisted tools to produce items faster and in larger quantities. Textiles, metal goods, and everyday tools would become more affordable and widely available. This increase in output would strengthen trade networks and stimulate economic growth across regions. Urban centers would expand as people moved closer to these new hubs of production. Towns would grow into cities much earlier, reshaping social structures. A new working class would emerge, made up of laborers who relied on wages rather than land ownership. This shift would slowly weaken the traditional feudal system, which was built around agriculture and local obligation. At the same time, new challenges would appear. Longer working hours and crowded industrial spaces could lead to poor conditions and rising social tension. Without historical experience to guide them, societies might struggle to balance productivity with human well-being. Economic inequality could widen as wealth concentrated among those who controlled technology and infrastructure. Technological progress would also accelerate itself. As production increased, better tools and machines could be built, improving efficiency even further. This cycle of innovation would push societies toward continuous development rather than slow, gradual change. Early industrialization would not simply speed up economic growth. It would redefine how people understood work, value, and progress. Long before the modern era, humanity would begin adapting to a world shaped by machines, setting the foundation for complex economies centuries ahead of the original timeline. As early industrial centers expanded, cities would grow at an unprecedented pace for the medieval world. People would leave rural areas in search of steady work, concentrating populations around production hubs. Towns that once housed a few thousand residents could rapidly transform into crowded urban centers, forcing societies to adapt to density far sooner than in real history. This rapid urbanization would reshape daily life. Housing would be built quickly, often without long-term planning, leading to cramped living conditions. Public infrastructure such as sanitation, clean water, and waste management would struggle to keep up with population growth. These challenges, which historically emerged during the modern industrial age, would now confront medieval societies with little preparation. A clear divide between social classes would begin to form. Those who owned machines, workshops, and electrical systems would accumulate wealth and influence. Meanwhile, workers would depend on wages and long hours to survive. Economic inequality would become more visible, replacing traditional feudal hierarchies with new forms of social tension based on labor and income. As awareness of these inequalities grew, conflict would become more likely. Workers might organize to demand better conditions, fair pay, or reduced hours. Without established legal protections or labor norms, disputes could be intense and difficult to resolve. Social unrest would become a recurring feature of city life rather than a rare event. Cultural attitudes would also shift. Ideas about fairness, work, and social responsibility would enter public discussion earlier. Writers, thinkers, and leaders would debate the costs of progress and the obligations of those in power. These conversations would shape laws and institutions over time. Urban growth and social conflict would act as a testing ground for civilization. How societies responded to inequality and change would determine whether early technological progress led to long-term stability or deep division, shaping the course of history centuries ahead of schedule. In the medieval world, religion played a central role in explaining how the universe worked. Natural events were often understood through spiritual meaning rather than physical cause. The introduction of electricity would quietly disrupt this worldview. A force that appeared invisible yet predictable would raise difficult questions about the boundaries between the divine and the natural. At first, electricity might be absorbed into religious understanding. Some leaders could interpret it as a sacred gift or a sign of higher power. Those who controlled electrical knowledge might gain spiritual influence, reinforcing existing authority. In this early phase, faith and electricity would coexist rather than conflict. Over time, however, repeated experiments would reveal that electrical effects followed consistent rules. Sparks, currents, and attraction would behave the same way regardless of belief or ritual. This reliability would encourage people to search for natural explanations instead of symbolic ones. Gradually, confidence in observation would grow stronger. As this mindset spread, religious authority would face new challenges. If electricity could be understood and controlled through study, people might begin questioning other explanations rooted purely in tradition. This would not erase faith, but it would shift its role. Religion might move toward moral guidance rather than scientific explanation. Debates between scholars and religious institutions would become more common. Some groups would resist these changes, fearing loss of influence or social order. Others would adapt, supporting learning and research as a way to understand creation more deeply. These tensions would shape cultural development for generations. This transformation would be slow but significant. Electricity would not directly oppose religion, but it would introduce a powerful alternative way of understanding the world. By encouraging evidence-based thinking, it would reshape belief systems centuries earlier, redefining the relationship between faith, knowledge, and authority. As scientific understanding of electricity expanded, its influence would reach beyond technology and into how people understood reality itself. Once societies accepted that invisible forces could be studied, measured, and explained through natural laws, this approach would begin spreading to other areas of thought. The world would feel less mysterious, not because it lost meaning, but because meaning was now grounded in understanding rather than assumption. This shift would slowly redefine belief systems. Explanations based solely on tradition would face competition from evidence-based reasoning. Phenomena once attributed to fate or unseen forces would be re-examined through observation and testing. Over time, people would grow more comfortable questioning ideas that could not be verified, changing how truth was defined within society. Education would play a key role in this transformation. Schools and learning centers would emphasize critical thinking rather than memorization alone. Students would be taught how to ask questions, test ideas, and revise conclusions. This method of learning would shape generations that value reasoning and adaptability, creating cultures more open to change. Philosophy would evolve alongside science. Thinkers would explore new questions about causality, responsibility, and humanity's place in a world governed by discoverable laws. Ethical systems might shift focus from obedience to understanding, emphasizing human choice and accountability. These ideas would influence legal systems, governance, and social norms. Importantly, this change would not erase spirituality. Instead, belief would become more personal and reflective. Faith might focus on purpose and values rather than explaining natural events. This separation would reduce conflict between belief and knowledge, allowing both to coexist in new ways. By reshaping how people define truth, science would leave a lasting cultural impact. The acceptance of reason and evidence would become part of everyday thinking, not just scholarly debate. Centuries before the modern era, societies would begin operating on principles that encourage learning, flexibility, and progress, permanently altering the course of human development. With a thousand-year head start in electrical knowledge and scientific thinking, humanity would advance at an unprecedented pace. Technologies that took centuries to develop could emerge far earlier, reshaping civilization long before the modern age. Complex machines, advanced infrastructure, and global systems might appear while societies were still adapting to earlier stages of development. This rapid progress would create extraordinary opportunities. Improved technology could enhance living standards, increase food production, and expand access to knowledge. Long-distance cooperation between regions might become common, reducing isolation and encouraging shared problem-solving. Humanity could reach levels of innovation far beyond what history records. Yet this acceleration would carry serious risks. Powerful technologies developed too early might outpace social and ethical understanding. Without historical experience to guide responsible use, societies could struggle to manage their own creations. Environmental strain, resource depletion, and technological misuse could appear long before systems existed to address them effectively. Conflict would also evolve. Advanced tools and communication systems could intensify competition between states. Power imbalances might grow quickly, increasing the stakes of political decisions. A single mistake could have widespread consequences in a world not prepared for such influence. The outcome would depend on adaptation. If societies learned to balance innovation with responsibility, early progress could lead to long-term stability and growth. If not, the same forces driving advancement could trigger widespread disruption or collapse. This final possibility defines the core uncertainty of early electricity. It could place humanity on a faster road to wisdom and cooperation, or push civilization into crisis before it was ready. The discovery itself would not decide the future, human choices would. To conclude, imagining electricity being discovered 1,000 years earlier reveals just how powerful timing is in human history. A single early breakthrough could have reshaped daily life, accelerated science, transformed governments, challenged belief systems, and pushed civilization onto a completely different path. From brighter medieval cities to early industry and deeper social questions, electricity would not simply speed things up, it would change how humanity thinks, organizes, and chooses its future. Whether that future led to lasting progress or early crisis would depend not on technology itself, but on how people learned to live with it. Thank you for joining this journey into an alternate past. If you enjoyed exploring this idea, do not forget to stay curious and keep questioning history. See you in the next story.